Hello, hello. This is Postgres FM. My name is Nikolay, Postgres AI, and with me, as usual, my co-host Michael, PG Mustard. Hi, Michael. How are you doing?
Hello, Nikolay. I'm good. How are you?
Very good, very good, very good. So it was my turn to choose the topic. And I chose the topic naturally. I thought we didn't discuss explain. Never, ever we discussed explain, right? We didn't do it. But then I Googled and found out that you discussed it without me. So I thought it doesn't count.
Nice.
Yes, let's discuss once again, but maybe going deeper in some places.
Yeah, I covered the basics, and I think it's a good suggestion to cover a more advanced topic. Like, I think explain is one of those topics that you can just keep getting more advanced, and there's definitely a level at which I'll get way out of my depth. But yeah, there's definitely room for a second episode where we go into more advanced topics for sure.
Right, and just to those who don't know, you spend like most of your professional time dealing with plans because PG Mustard is analyzing, PG Mustard is helping people analyze and approve queries, particular queries, looking at explain plans, right?
Yeah, exactly. It's a visualization tool for explain, and then also tries to provide performance advice based on that. So we get normally people's more complex query plans. So I guess this is an area that I've got more practical experience than most. Obviously, everyone knows when you're building something, people that build healthcare software aren't always intimately familiar with everything about healthcare. Like there's like certain things you get really familiar with, but you also end up having to deal with things that are just not to do with that at all. But yeah, I have over the past few years come across probably most variations of how performance problems can be shown via explain plans. I have some blind spots for sure, but yeah, it's been a big thing for me. But also for you, right? Like this is a big part of your work's been performance consulting, it's hard to do that without explain.
For me, explain is the not number one tool usually because except cases when a customer asks us to help with specific query, which happens as well, but usually we deal with analysis, like top-down analysis of whole workload, and we start with PG star statements and wait event analysis, performance insights, and RDS or something. And then we go down, and when we identify first aggregated query or normalized query in official PG star statements terminology, and only then we find examples of bad behaving query. Then we discuss like how to improve, we need to a playground, we need a proper playground, and maybe we will want to discuss how to make it so explain plans match what we see in production. And only then we go and check the actual plan and try to improve it and so on. Sometimes we have all the auto-explain, right? Auto-explain is a great tool.
Yep. We did an episode on that too.
Yeah, I remember. And yeah, if you have it, it's great. But it's not always so. It's not enabled by default, and it requires some effort to be enabled. Although it's present, it's available everywhere. So I wish I saw it more often, right?
Did you see I did a blog post on this year on which cloud providers provide access to explain and which
I
parameters?
Don't remember, honestly. I need to check it.
Yeah. I'll share it. It's not the most interesting read, but it's like a good reference, and like I find it useful for if somebody mentions a cloud provider to me, like one of our customers.
So everyone has it, right?
Yes, pretty much. Not quite everyone, but like pretty much everyone, and most of them provide access to most parameters. So explain and auto explain have a bunch of parameters, and I found it hard to check which ones offered which parameters. And I've got good news as well, actually. I got a nice direct message from somebody who works at AWS, and the parameters they didn't offer, there's like 2 or 3 that they didn't offer, they've submitted a pull request for. So I'm looking forward to the next release of the RDS products, which I think will include those.
That's good. So yeah, of course, we also deal with explain, but it's just one of things, and we probably don't dive too deep as you do. So where do you want to start this discussion?
It was your suggestion. Where do you want to start?
Oh, but you are expert, right?
Okay, all right, maybe. I'm not sure. I still feel really uncomfortable with the word expert.
I'm feeling very uncomfortable with the word analyze. It should be execute, not analyze, right? In the explain comment.
Naming. I've been thinking about naming for a while with this because part of our tool, we give people something to copy and paste so that they can easily copy it and put it in front of their query if they're using a like P-SQL or an editor or something. And it's getting longer and longer. The more parameters that get added to explain, the more and the more information, the better for when you're using a tool. If you don't have to worry about it the output getting long, and your visualization tool should be pointing people at the right place anyway, the amount of data is the more the better, really. The more information you get, the more likely it is you can point out the problem. However, that it's become explain and then in parentheses, analyze, buffers, verbose, settings, format JSON, and there's more. There's there's serialize and memory, but most of these are off by default. So you have to specify all of them to get all of the information. So analyze is one of them. But the reason I was thinking about naming was I wondered if I was wondering about suggesting something like explain all. But the problem with that is there's so many pieces of advice out there in the wild about when you run explain analyze, be careful because your query will be executed. If your query is data modifying, it will modify the data. If your query is long, it will take that amount of time to run. And all of that advice would become not obsolete, but if we change the name, all of that advice becomes difficult to you have to go back and change all of the advice, or you have to add, if you want to explain, analyze, or explain all.
For 5 years, the old word could be supported, but it's so confusing to explain people that analyze is actually executing the query, and it's not the same analyze as analyze table name, which also affects probably plan, but you need to understand this. Right? If you run analyze table name, probably after that you will see different plan in explain and explain analyze, but it's not because these two words are the same words. So they are very different words, right? Remember we discussed Postgres 17, it was confusion resolution. I wish this confusion one day would be resolved as well. Right.
Oh, I agree in principle. I just think in practice it would be painful.
Why painful? The word execute is not used yet. First we introduce synonym, and then we in 5 years we ditch the old word.
It's used in prepared statements, right? Prepare, execute.
Yeah, but execute means execute, and analyze and explain also means execute. Okay,
true.
By the way, let me confess about something related to prepared statements. A few weeks ago we had episode about planning time, right? Which also related to our today's topic, because planning time we check using explain mostly. Of course, we can check it in PG-star statements, but again, not everyone enabled track planning in PG-star statements. So usually we just check in auto-explain or regular manually in ad hoc way. We check using explain.
Not auto-explain, sadly.
It cannot show planning time? Wow.
No.
Okay. Good to know.
But in PG-star statements, if track planning,
Yeah, if track planning. So if we, for example, deal with partitioning with high number of partitions, planning time increases, as we discussed. But as I just blog posted about it, and right after that we had a discussion on Twitter, and it turned out that my experiment was wrong, and my ideas not fully wrong, right? But not purely accurate, because planning time is affected only in the very first time when query is executed in a session. If you execute it once again, we already have relation metadata cache, rel cache, and overhead becomes almost zero. At least for simple queries.
Yeah, simple queries that can prune down to a single partition, or a low number of partitions. And it was David Rowley Rowley?
Yeah.
We pointed
Yes,
that
of
out,
course. If there's no pruning, then it's a different story. Of course, the number of partition growth, more work needs to be done at planning time. But yeah, I'm talking about partition pruning happening at planning time. The idea is only the very first execution suffers.
It's so, I mean, I'm really impressed David noticed that so quickly.
Yeah.
I mean, he knows his stuff around this topic. I'm pretty sure he was involved in the fixes. I think it was in Postgres 12 to improve that exact metric. So, yeah, kudos to him for pointing that out so politely as well. I think he said it was misleading, not wrong. Yeah. And also, really good reminder. Do you remember when we had Melanie on to talk about benchmarking, how difficult benchmarking was to make sure you're measuring the thing you think you're measuring?
Yeah.
It's just a good reminder. Like, these things are so difficult, but by publishing them, by publishing your findings, and by the Postgres community being so open to to correcting us when we're wrong, we've all learned something. I think that's
exactly. It was very good, and I cannot agree it's wrong because there was no mistake there. There was just there was a problem that the experiment didn't do next step, which of course I should do. So it's actually misleading is a good term here.
Yes.
So I extended blog post like right away.
Nice.
And it turned out if you use just explain, no execution, no analyze word. If you just use explain, you add partitions. We checked from 0, 100, 200 and up to 1000. And you see using explain, select, primary key lookup, and partition key basically lookup. And you see, first of all, you see index scan, only one partition. So partition pruning is working at planning time. But planning time grows linearly with number of partitions, and number of planning buffers also grows linearly for this kind of query. And it was range partitioning. We didn't check others. But once you run explain once again in the same session, only 3 buffer hits. Always, regardless of number of partitions. And also good relief, right? So you think, oh, it's great. I'm going just to relax and I can have 10,000 partitions for simple queries like this. Of course, complex queries will be different, I'm quite sure. But if partition pruning works at planning time, I'm happy, right? It just tells me I need to take care of proper connection pullers. So I need to have them always. And interesting that the problem with our discussion and my ideas a few weeks ago when I said like, oh, if you have high overhead of planning time, which obviously it's only for first execution planning. In this case, just use prepare statements. But this is definitely maybe not only misleading, but also wrong because as I actually learned in detail, if you use prepare statements, you see that partition pruning shifts to execution. So the plan, a generic plan, includes all partitions, right? Because we cannot cache the plan which is dealing only with single partition in this case. But what if we need to execute the prepare statements with different parameter, right? We need different partition probably. So the cached plan includes all partitions, and you run explain for prepare statements for specific parameter, and you see that execution time, you see subplans removed, right? This word in explain. This is interesting, which means that overhead shifted to execution. It's not good, right? But again, which overhead? If we have real cache here, all good. Right, so it means that for high number of partitions, not prepare statements matter. Like they can help, but they don't help fully because of this shift of partition pruning. But what actually helps a lot, pullers, right? We have pullers in all heavily loaded projects. And if you are preparing to have huge tables, like we always say, if you exceed 100 gigabytes, you need partitioning, but it also means you do need proper connection pooling and avoid the initial overhead of planning, basically. With high number of partitions, planning will be not good, right? Yeah. So back to explain.
Yeah, question back to explain, kind of linking them. When you did the second explain, extracting the buffers and things, did you use format JSON for that and parse the
No.
output, or what did you do?
It was in
Text.
yeah, it was text regular.
Yeah.
With
Just parsed it.
settings, yeah. Yeah, and it was done by our AI, so it doesn't use JSON at this point. Just we don't want very bloated format, and yeah, and actually, yeah, we needed to fix how it works, because right now it works through PsychoPG, so Python, and yeah, it's supported. So if you run a couple of explains in one shot, it received only one result. We fixed that, so now it sees both results. And second result is always, in our case, 3 buffer hits. So planning time remains way below 1 millisecond, like I think maybe 10 microseconds or so. It's so super tiny, almost zero. And the bottom line here is that, like usually we say, if you run explain, analyze, buffers, of course. We had a couple of episodes about it, right? If you run it, always run it a couple of times, maybe a few times, because of caches. And if you want to check timing, if you're too obsessed by timing, not my case. I'm obsessed by buffers, not timing. But you need to run it multiple times to check the second execution, because first time probably everything is not cached, data is not in the buffer pool, and not in page cache. So run it twice. That's a good piece of advice, right? But what we just discussed means also that even for planning, run it twice in the same session, right? Because maybe you observe a lot of work if partitioning is involved, especially if a lot of work related to lack of rel cache.
I've seen this. The other weird thing I've seen, I don't know if you know the answer to, is you can do like a simple ID lookup, like primary key lookup, and you will get planning time, but no planning buffers reported, even if you include the buffers thing.
Yes.
What's that? How's like
it's
how
a bug,
is it?
I think. Yeah. Yeah. Inside my team, like last week, since we worked on this blog post, a couple of other, like many people actually were involved, but this particular problem was very annoying. Very annoying. So, like, why buffers are not reported in planning? Okay, now they are reported, and we cannot understand on what it depends, right? So, once we understand, probably it will be a bug report already, right? Because it's something wrong is there, because we requested.
Yeah. It's weird, but I mean the text format's hurting you there, because by default in the text format, if things are 0, they don't get reported. It's like roughly a general rule.
You think
Whereas
so?
in JSON format, you'd still get buffers reported, but they would have zeros. It's not much better.
In our case, it should be reported, because it always was something like some number of hits. But yeah.
So that's a different bug, right? Like all I meant is if planning buffers
are 0,
but I don't understand how planning buffers can be 0 if it's actually doing work, if it's actually picking which index to scan. So I found that
in the case of prepared cached plan, if plan is cached, there is still some planning time, but I suspect this planning time occurs during execution because of these subplans removed and partition pruning happening. I'm not sure, by the way. This is some nuance.
I think maybe like parsing might count as planning, or like I think there's other steps.
Well, I'm looking at it right now. I'm looking at a plan which checks execution of with force generic plan cache mode set to force generic plan, and we check execution for prepared statement. It's cached, the plan cached, and we see no buffer planning related buffers reported at all. Like it's missing. But planning time is like 38 microseconds. And partition pruning happened at execution time. So I wonder, what are those 38 microseconds? If plan is cached, maybe just additional checks, I don't know, like It's
You know, there's
interesting, right?
multiple stages. Like, you know, I can't remember all of them, but one of them, for example, is parsing. One of them's like rewriting. So like you might rewrite the query. I think some of those get bucketed at the moment as planning.
So if probably you're right, and there are no buffer hits involved at all, and that's why it's not reported at all.
But I've seen this. I've seen zero reported when it's like not a plan cache. Like if it's a primary key lookup that you've run. Well, yeah.
So where there is some work for sure, right?
Yeah, right. Or like in my head, it would make sense that there's work. Anyway, it's an interesting quirk.
And even if it's not a bug, the fact that you raise this topic and we discuss this topic inside my team, it's already something, right? Which is not clear.
Yeah.
And yeah, if someone who watches us who is more experienced than us, please tell us. This is super interesting piece of information, right?
Yeah.
So what I wanted to say, you need to check the execution of explain for planning for the second time inside the same session, just to exclude the fact that you observed overhead from lack of rel cache. This is a lesson I learned last week. And this is correction to ideas I expressed a few weeks ago in the planning time episode, right?
And there's some good practices like that help mitigate this kind of issue. Anyway, like normally people when they're benchmarking or testing things will run something 5 times and maybe take the best of the 5, or running things multiple times. I don't know if you've ever seen some sports do like diving, for example. They give people scores out of 10 and then they cross out the top scoring judge and the bottom scoring judge.
Yeah.
And yeah.
Actually, we did it.
Do that.
We did it, but we due to some reasons, it was not like we plan to improve this, and this kind of analysis should be done in exactly that way. You run multiple times, you check which data points are way off and exclude them, and then you take average. That makes sense totally. But in this case, just how we did it, it was a single session experiment, and we ran all explains. So bottom point, like if you run explain 5 times and every time it's a new connection, right? It's still, the problem persists.
Good point.
Yeah. You need to run it multiple times inside the same connection. And then I would not agree with excluding the first one due to lack of rel cache, because it's also an interesting fact that with growing number of partitions, the very first execution, like it can reach dozens of milliseconds and even 100 milliseconds. It's a lot. So it means connection poolers are needed, and they need to be configured properly if you have thousands of partitions. Otherwise, the fact, like, it will be very often new connection established, query executed first time, huge number of partitions, and you have penalty of dozens of milliseconds. For heavily loaded projects, it's a lot, maybe 100 milliseconds. It's like huge overhead. And this fact also interesting, right? So we learned 2 facts. That overhead is huge, linearly growing for this particular simple, very trivial case. And there is basically no overhead for subsequent queries. Wow. This is like a sequence of surprises for me in this work. I like it, actually. So yeah, let's maybe switch to another topic. Maybe you have some ideas what to discuss next.
Yeah, well, when I think of advanced explain, I'm thinking more like advanced query optimization. Maybe you're familiar and got good at reading explain plans when it's a relatively simple query, maybe some normal scan types, some normal join algorithms. You're somewhat familiar with it. You can work your way around that. But I've spent several years looking at this, and I still from time to time see operation types that I've never seen before. And things get complex, like in terms of how many operations there are, or things that complicate things like CTEs and init plans and kind of things happening, which order things happen in, things happening at the same time. I think we had Haki Benito on relatively recently talking about how if you have multiple CTEs, those happen at the same time and independently of each other. So like that's confusing, and like how those appear in explain is interesting, but because it's shown as a tree, and they have to kind of work out different display mechanisms for how, for showing that. That's not necessarily misleading because it's hard to say how you should visualize that. But that's what I'm thinking in terms of like advanced topics around explain. How do you interpret those? And also, what can you ignore? Like, what if you want to do this? Normally, your aim is kind of speed this up. And if as things get complex, you often want to simplify. Like, what can I do to discard a bunch of this information? Like, which bits of this are already fast that I can ignore? Maybe I can run a simpler query that's only the part of the plan that's problematic. Like, that's what I'm thinking in terms of more complex topics.
Right, I agree. Reading complex plans. This is it. Yeah, I agree. And here actually, what helps? Experience helps definitely, because I usually like buffers for me is a must, right? Buffers is a must, and I start reading, okay, execution time, planning time, but I read, quickly scan buffers, and they are like cumulative, like they are accumulated to the root, right? And the root includes everything. So you can see and go from root to leaves, basically. It's like upside down tree, right? So we go top down analysis again. We understand the number of buffers, we understand how many megabytes or even gigabytes sometimes it is if you multiply by the block size, which is in most cases 8 kilobytes, right? And then we go down and see where exactly this huge volume came from. This is my default type of work with plans, including execution, of course, right? Because if you don't have execution, you only have cost, and buffers are reported only for planning, as we thoroughly discussed, right? So, in this case, usually it helps. In most cases, it helps. And I wish I also was able to see log-related information, right, in explain plan.
Yeah. Right? Like weights. Yeah. It's difficult to see how they would do that, but
not necessarily weights.
What do you mean by logs?
If actually maybe you're right. Yeah, what's happening under the hood slightly, but it's already super complicated output, right? So,
yeah, and it's there's macro versus micro issues here. If you're on a test environment where you're the only person there, it's much less likely that you're going to be
originally when I said logs, I was meaning heavy logs. So like at planning time, all indexes are logged, and all tables and all relations are logged, and that's a lot of overhead. I wish I saw it. It's interesting information. Access share log for all of them. So, and if it's update, okay, what kind of log I have here?
Oh, interesting. Yeah, that's not what I was thinking at all.
Yeah, you thought about lightweight logs. Yeah.
Well, no, I was even a different
or weight events.
I was thinking like easiest experiment to show this is strut one transaction and maybe do some DDL or maybe drop a column or something. Yeah, anything that's going to add a huge like a really heavy lock on that table. Then open a second transaction, just do a simple select query on that table. Go back to the first transaction and commit. Go back to the second one and see that your query was just waiting that entire time. If you ran that query with explain in that second
if you committed, it's not waiting anymore.
Well, but the execution time of that explain will be huge.
Oh, yeah. You're right. And this execution time can be explained if we saw like basically a pie chart or something, or like distribution.
Or like there will be no node. Yeah. There'll be no operation in that explain plan that shows that it was waiting on an exclusive lock. It will just show that one of the operations was extremely slow.
Simple wait event analysis for this particular session would help.
Yes, but
explain
it doesn't
technically.
It doesn't come up that often to me. Like I don't. Maybe it's like one of the blind spots because I don't see those. But I don't see plans that have these really unexpected bottlenecks.
I would like to be able to, not by default, but I would like to be able to see this wait event analysis and have logs as well, because I want to understand this query, which logs it's going to acquire when I go to production, right? When execution finished, what logs were acquired, right? Yeah, I think interesting like extensions, but it's already so huge. Yeah.
And as I mentioned, right, we're getting more and more. I think this is part of the reason people are adding more parameters to explain. So right ahead logging information.
It should not be by default. It's too much.
Well, I actually have a proposal here. I haven't suggested it on any of the mailing lists yet, but I would like your opinion. I thought about adding them by default when you include the parameter verbose. So if you do explain, analyze verbose, give me everything. Like,
you
give
just
me
don't
buffers,
want to update your website with snippets.
Yes. Yeah, I don't want to update that snippet for sure. But also I want people to only have to remember to do that, and they'll get whatever Postgres can give them. Verbose means like really long. Give me it means everything. It kind of means like, I'm okay with loads of information. Give me it all. So it's already kind of in the meaning. So I don't, anyway, I haven't proposed it yet, but that would also come with buffers. So I thought you might be happy.
And also, if you talk about what's missing and what you cannot get from explain, I also like at some point, maybe some extension of this could be, imagine if we see operations at disk level as well. And we understand not only hits and reads for the buffer pool, but also hits and reads for page cache, for example, and maybe CPU analysis as well for this particular execution, if it is explain analyze. Right?
That's a good point. It's not exactly what you're talking about, but loads of people don't realize, because it's not an explain parameter, that you can, with track IO timing on, you can start to get some insights into the disk level performance. And that's improving in each, there's recent, even in 17, we got some improvements there. So like buffers are split into shared, local and temp. IO timing wasn't initially, and is now split into all three.
Yeah, that's great. But I'm talking about like basically pg.k cache, but for explain. Physical.
I understand, but the timings are a good start, right?
I agree. Yeah. And actually, I think it's possible to have all of this right now already, but you need to connect many pieces. And for example, it could be a tool which runs explain, but also looks at wait event analysis for this PID in pg.stat activity and logs as well. And what else? Like collects everything and big report for a particular query. And also physical. Yeah. Physical, we can, if it's have physical access, we can do it from proc. Not knowing PID. This, I think we had prototype for our old bot. Yeah. So it's like you just counters from proc.
You can get, because you've got the query identifier, which is the normalized one that you can match to like pgstat statements. I imagine you could start to tie all of these things together.
Yeah. A lot of stuff is possible. Who is doing this, by the way? Maybe someone is doing this.
I don't know the monitoring tools well enough to know who's doing some of this micro level, but if they are, let us know. Like if you're using one or if you're building one that does, that would be cool to hear. To be honest though, this goes back to some of the conversations we've had about the macro to micro zoom. Like once you've done your macro analysis and you've identified a few problematic query, the main consumer, if you've got a few bottlenecks, explain's a really good tool for doing that micro. Like once you've got a sensible set of parameters that you know will be slow, it's not that hard. It's not that hard to reproduce normally. The difficult thing is then going through a 200-line explain plan. And you asked what can help. I think we've put a lot of effort into helping with that stage, and a lot of the other tool providers have as well. One thing we do that I think is really helpful is if a sub plan is fast, as a proportion of your query, we collapse it by default. We hide, we don't hide it. We just say there's 20 nodes here.
Everything is fine there, right?
Probably you don't want to look here, which means that a 300-line plan can go down to 20.
That's cool.
But that those kinds of things I think can really help initially. It's not good for a hacker. It's not good for a Postgres hacker that's trying to work out the cost model for a new feature. But for somebody just trying to speed up a single query, you don't need to look at the 200 partitions that all took or that were never executed, or that took 0 milliseconds.
Yeah, and you mentioned query ID, and for example, like I think it was last week, we were working with one of customers. We saw that auto-explain was used, and it's great. And there was a task to analyze a lot, and we still plan it. And I'm very thankful to you that we have integration with our AI right now, and your system helps our system. And I plan to perform some massive analysis at larger scale and to be able to do it. But the interesting thing is that if you want to analyze a lot of queries from auto-explain, you do need you basically need to compute, it's called compute query ID parameter, right? You need to turn it on because by default it's auto, and for auto-explain it will not work. And
it does if you have verbose on.
Okay, in auto-explain.
Yeah.
Okay, in our case we didn't have verbose on, and I think, right? So,
but only as of 16, I think.
It's better to turn it on, actually.
Maybe, yeah.
Yeah. Question of overhead, and let's, by the way, talk about overhead in a second. But if you imagine you have a lot of query cases, various queries from the log, presence of query ID first gives you understanding how many different normalized or aggregated queries you are dealing with, right? And second, you can then join this information with purchase statements and go to macro level back and understand, okay, this query is not very influential because it's tiny part of, or maybe vice versa, it's influential, although we see only few occurrences in our slow log because we have threshold, right, by time, auto-explain mean duration, right, query mean duration. We usually set it to 1 second, for example, right? And if we have only few cases, but we see in workload, this is actually 50% of all total exact time. We do need to think about it properly, and influence of this optimization will be high, right? So let's do it. This helps understand, when you have a lot of queries to deal with, where to start, right? You want to start with most influential steps. So query ID is good thing, and I'm glad we have it everywhere in explain, in the logs, in purchase statements. You can connect all the dots, and purchase activity as well, right? So you can, wait event analysis is possible just joining by query ID as well, if you run many times, right? So yeah, great. What about overhead? I think it's also an advanced topic. I know you blog posted about it, and Ongress did. You talked about auto-explain, right? But explain itself also has overhead.
Well, explain, and I'm not. Yeah, explain can have both. Can underreport and can overreport the timing.
Timing, I'm not a fan of timing.
Well, but bear with me. I think people focus a lot. Well, there's different things. The Ongress thing was about the queries being slower. You actually cause some overhead by observing. And that's true when you're running explain analyze with time, because timing is on with analyze by default. But it's also true if you're running auto explain. There's also some overhead to measuring and to logging. If you log a lot of plans, that's some overhead as well. So there's those overheads, but there's also the possibility that it underreports, which I think throws some. So this is one of the reasons they added the parameter serialize. If you are doing a lot of work after the query is executed, but in order to send the data to the client, nobody really cares about the server side time. That's not the big, the server side time is important, but it's what we get from explain analyze. But what they normally care about is the user experience, the full client to server to client time.
I cannot agree here, but okay, go on.
Okay. Well, what I mean is, if you're getting a report for my dashboard is slow, there's no point only speeding up the server side time. If you're sending
we need to look at
amounts of data,
parts.
Yes, and part of that work is, so serialize is part of it. It's getting the data ready to transmit, and then there's the network overhead as well, like of actually sending all that data. So yeah, I guess
it's
you're
not,
right.
It's not network cost. It's not like transmission cost. It's a cost of not cost. Cost maybe not a good word. It's overloaded here, right? It's time, right? Or cost. It's cost. It's cost.
Serialized
actually, right?
Serialized is reported as time and amount of data.
What cost? Okay.
I actually don't think it has costs relate. Like, I think it's one of those things that gets reported in like the summary section. So like just in time compilation and planning.
But it's about serialization, not transmitting.
Yes, it's a step before getting the data ready to transmit.
Still everything on server.
Yeah, for example, uncompressing or decompressing toast data.
And it's Postgres 17 feature, right?
Yes.
So it's just goes deeper to understand what's happening on server side, like execution, and what part of it is associated with serialization, attributed to serialization, right?
Well, and not just that. Before, if you ran explain, analyze, select some data that had been toasted from this table, you would get a really fast execution plan because it wouldn't do the serialization. Like, it would say this executes really quickly. So it wasn't just that you couldn't see the time. It was like a query that might take 100 milliseconds when you run it from pSQL. If you put explain analyze in front of it, it could run in 1 millisecond or 10 milliseconds, much, much, much faster. So because it didn't have to do that expensive step.
I see, yeah.
So this is one of those cases that used to be, and not just used to be, like by default, this is still the behavior in version 17. If you run explain analyze some
select star from blah, blah, blah. And
yes,
before 17, we didn't see this part at all.
Even in 17, you don't see it unless you also explicitly ask explain, analyze,
That's bad. I like defaults.
That's just what I've been saying. Yeah.
And what about verbose? Verbose includes it, right?
No, it doesn't.
No?
This is my proposal that verbose should include all of these additional parameters.
It should, of course, I agree. Yeah. Well, okay. It is as it is right now. So,
and I have to actually say, explain is awesome. Explain in Postgres in particular is the best I've seen of any database that I've worked with. Other data, like MySQL, for example, is catching up. Like they got explain analyze in version 8, but the amount of data we can already get is is beyond the other open source databases I've seen. So it is good. It's just always can be better, right?
Yeah. If somebody is watching us thinking, oh, a couple of haters, right? Haters of explain.
Yeah, absolutely
it's just
not.
A lot of stuff. Yeah. But a lot of stuff is helping all the time. It's true. Do you want to discuss overhead from like buffers option?
I couldn't, when I did one really basic experiment where I did very, very small queries, but I couldn't get any additional overhead. There wasn't like a measurable extra overhead of requesting buffers. I think you said you did an experiment once that did show it, but I don't remember.
On timing, it cannot, like buffers are they're basically invariant. Of course, they can be hits or reads or they like moving back and forth. But if everything is cached, it's very stable. Like you're reading the same data, like same query, just select multiple times, you will see same number of buffers all the time. That's like one of the things I like them, reasons because I like them. But if you include buffers, I did see in the past, it was some time ago, the timing is increasing, right? Because a lot of buffers need to be reported and counters inside need to be presented. If it's a complex query, in many places, this overheads adds up, and the timing without buffers option is very different compared to with buffers.
I've seen single queries where that's true, and I think Lucas Fittel from PG Analyze has done some examples of this. I've only seen it in queries that have nested loops with lots of loops. Like that's the example everybody turns to.
For example,
it's common.
Join with nested loop.
Yeah, but the reason I think it's slightly overhyped is when you're optimizing, you don't always care. Like if the explain analyze is 4 seconds, or maybe let's pick 400 milliseconds, and your real execution time is 300 milliseconds. If you can speed the 400 milliseconds up to 50 milliseconds, the 300 might go down to 40, and directionally you're still looking for the same things. And by asking for buffers information, you're getting more information. You're more likely to be able to optimize your query. So exactly. I don't care as much as most that it's like slightly different.
I only care that including buffers don't change buffers. That's it. That's it. So for me, when I start working with buffers, I'm less concerned about timing. Focus on buffers, optimize, and then go back to result and see, timing is improved drastically because we reduced number of buffer hits and reads. Right. So that's it. This is very, very common path for me. Just reduce because you like sequential scan, lots of buffer hits and reads. We are at edit index. Okay. Couple of 3, 4, 5 buffer hits, that's it. Time to look at timing. Of course, expected 1,000 times faster, right?
I like buffers a lot, but for me they'll always be secondary because if you look at timings first and last, that's the main aim. Like the main aim is to get things faster. And yes, like in 90% of maybe 99% of cases, it's going to be IO that's the limiting factor. But in some queries, there'll be like a sort in memory. Like there'll be something that doesn't report extra buffers in explain, that like there'll be some like just in time compilation, or there'll be some limit, like maybe trigger timing.
Just time compilation is off.
But all I'm saying, or planning time, actually planning time, you now do get buffers, but right. Trigger times, just-in-time compilation, there's like a few other examples, sorts in memory, hashes in memory. Like if some of these other bottlenecks don't report buffers, why not like look at timings and then buffer? Like I almost always see query plans with both these days, so it's
That's
kind
great.
of like
yeah. That's great that buffers are present. If I'm not, at some point I started saying if there are no buffers, I'm not dealing with this query. This is what I say to customers, that like go and give me with buffers because we are missing super important. Okay, if you put it to second place, this place should be always present. So
I'm sure we talked about this before. I think that's probably enough. I've got a talk that I gave a few years ago called Explain Beyond the Basics, which I would have thought we had covered some of the bits of, but actually I took a completely different path there. I went down kind of some of the less common types of issue that you can spot with Explain, which we haven't really talked about. So I can include that as if anybody wants to know a bit more of the specifics. It's a bit nicer. Like that format is good because you can actually see examples of Explain plans. So it's probably a bit better video wise. And yet the reason I see buffers more often now is everybody suggests adding it. But also some of the other tools as well, like Depeche added it to the default thing that he suggests people get. So there's loads of people. Yeah,
that's news to me. I remember it was missing, and it was big disadvantage.
He added it. It's great.
That's good. That's good. Yeah.
Anything else you wanted to add?
I think it's enough.
Me too. Nice one.
Thank you. See you later. Bye.
Thanks so much, Nikolay. Take care. Bye.